This is day 20 of coding every day until I hit 1K subs. So today I bumped up the version for my Talktollm project from 0.2.7 to 0.3.0. This is the little Python tool I'm building that uses screen recognition to let you talk to language models like Gemini or DeepSeek right from your terminal. Let's quickly look at what changed. The core idea is still the same, but version 0.3.0 focuses heavily on making things more robust and reliable. For instance, handling the images needed for screen recognition is now safer. It checks if files exist, handles errors better if the package wasn't installed quite right, and only copies images if they're newer. Also, if the optimize wait library isn't found, it now has dummy functions, so the program doesn't just crash immediately. Big part of the update was improving how the script interacts with the Windows clipboard, which can sometimes be a bit finicky. Both setting text and setting images to the clipboard now have more retry attempts if access is initially denied. The error handling is more specific, catching common Windows errors and trying to close the clipboard properly even if something goes wrong. The main Talktollm function also got a retry mechanism specifically for reading the final response from the clipboard, making it less likely to fail if the copy action takes a moment. This is just a visual reminder of the project, automating browser interactions with LLMs. The recent updates were mainly about making that automation smoother and less prone to errors, especially around clipboard operations which are key for pasting prompts and copying responses. Alright, after tweaking the Talktollm project, I jumped over to LeetCode. Today's problem is number 2503, maximum number of points from grid queries. Quick spoiler alert if you want to try it yourself first. The basic idea is you're given a grid of numbers and a list of queries. For each query value, you start at the top left cell 00 and can move up, down, left, or right. You get a point for visiting a cell if the query value is strictly greater than the cell's value, and you only get points for the first visit to a cell during that query's exploration. The goal is to find the maximum points you can get for each query. The core idea to solve this efficiently is to process the queries and use a union-find data structure. Instead of running a full search for each query independently, we sort both the grid cells by their value and the queries by their value. Then, we iterate through the sorted queries. For each query, we first add all cells with values less than the query value into our union-find structure. When adding a cell, we also try to connect, union it, with any adjacent neighbors that have already been added, meaning their values are also less than the current query value. So here are the helper classes. Cell and query are just simple containers to hold the data along with original indices or positions. The important part is the union-find class. Think of it like grouping people into friend circles. Find tells you which circle someone belongs to, and union merges two circles if someone from one circle becomes friends with someone from another. We also keep track of the size of each circle, or connected component in our grid case. The get_size method tells us how many cells are in the same connected group as a given cell. Here's the main logic. We sort the queries in the cells. We use cell_index to keep track of which cells we've added to the union-find structure. As we go through each sorted query, the while loop adds all the newly qualified cells, those with value less than the current query's threshold. When adding a cell, we check its four neighbors. If a neighbor is valid, within grid bounds, and its value is also less than the current query threshold, we perform a union operation. This connects the current cell to that neighbor's component in the union-find structure. After processing all relevant cells for a query, we check if the starting cell, 00 itself, has a value less than the query threshold. If it does, the answer for that query is simply the size of the connected component containing cell, 00, which we get using uf.get_size 0. Otherwise, the answer is 0. This approach is efficient because each cell and query is processed essentially once, dominated by the sorting step, making it roughly run in n log n plus m log m time, where n is the number of cells and m is the number of queries. And that's day 20. We looked at some robustness updates for the Talktollm project and tackled a LeetCode problem using union-find. If you enjoyed this or found it helpful, please hit the like button, subscribe if you haven't already, and maybe leave a comment letting me know what you're working on or what kind of problems you find interesting. If you'd like to support the channel further, you can head over to buymeaboba.com. The link is in the description. Thanks for watching, and I'll see you tomorrow.